Hey everyone, this is just a quick video to demonstrate how refinement types work in Vortex. So a refinement type is essentially a function that acts as a type, and you'll see what I mean in just a second. But let me just explain what I have over here. So I've got a couple things in this file. I've got a print line statement that says runtime, and I've got a type definition. The reason I have this print line statement at the top is to differentiate between runtime and compile time when we see some errors appearing in the console. And you'll see what I mean in just a moment. The next thing I have is a type definition. So I have a type here called greater than 10, and it's essentially a function that takes a number and checks if that number is greater than 10. But because it's a type, this can actually be used as a refinement type. And what I mean by that is if I have a variable, let's call it x because we are very creative, and then give it the type greater than 10, and then give it a value that's less than 10, and I go ahead and run this, I'm going to get a compile time error. Now this error is saying x expects a value of type greater than 10, but receive value of type number. And all that's saying is, look, we've completely failed this type check over here. So you've given us something that doesn't satisfy this type. But if we give it something greater than 10 and run this, we'll see runtime is now printed because we've passed the type checking stage and we were onto the runtime, which is all good. How do we then use refinement types in functions, for example? So if I have something like const func, again, because we're very original, and then x is a parameter that takes in a greater than 10 type. And for the sake of this video, we'll just say, look, we'll print line, hello there. Now, if we run this, it's all well and good. It's completely statically type checked, and that's fine. If we run this and we give it a value that's less than 10, we yet again get another compile time error. Now, this error is basically saying, look, we've looked through all the functions called func, and we can't find anything that satisfies what you've given us. We found a function that satisfies x being greater than 10, but not what you've given us. So essentially, it's an error saying, look, this failed at compile time. If we give it something that's greater than 10 and run that, you can see that everything ran perfectly fine. Now, what if I wanted to change func just a little bit so it accepts a number? And then inside the body of that func, what I want to do is assign another variable, say g, but I want that variable to be greater than 10. And then I assign x to it, for example. Now, what do we expect to happen when we run this? Well, if we go ahead and run this, you'll notice that we do get an error. Again, it's a compile time error. So we get g expects value of greater than 10, but receive value of number. But this is failing at compile time. How do we then make sure this function is actually statically type checked and then fails at runtime, which is what we actually intend here? Well, what we can do to get around that is use generic functions. So instead of const, we'll replace const with type. And in Vortex, what that does is it makes sure that func is now a generic. So we can go ahead and get rid of this type over here, and now func is truly a generic function that accepts anything and then gets reevaluated once we have a value. So if we go ahead and run this now, we'll notice that it does pass compile time, and it goes all the way to runtime, and it's all good. If I go ahead and run this though with something that's less than 10, what's happening here is, because it's a generic, x is going to take on the value of 4, and it's going to get reevaluated again at compile time. So if we run that, again, we see that we fail, because 4 is obviously less than 10. But if we give it something greater than 10 again, all is well in the world. Everything functions as we expect. So how are refinement types useful? Well, they're pretty handy when it comes to things like multiple dispatch, which Vortex offers. So if I have something like a function, let's just call it func yet again, that takes in x, which is a greater than 10, and let's say it prints greater than 10. And let's say we have another function also called func that takes in just a number, any old number, doesn't matter what it is, and then this prints less than or equal to 10. So what we've defined here is multiple dispatch. So essentially what it means is if we run this function and give it something, it's going to go through each and every one of these in order, and whichever one it matches first, it's going to run. So let's see what happens if we give it a func of 4. It goes less than 10, and that's because it did not match on this. It failed the type checking here. However, it didn't fail on a number, and it prints this instead. If I give it something like 40, then you will see greater than 10. So this is a very simplistic example, obviously, but it does demonstrate how refinement types can be used and how useful they can be, especially when it comes to multiple dispatch.